of my demo for, what is it? Target 10A. And for this task, we were asked to build a 4-bit serial adder. However, instead of using a shift register, we are using a universal register, and we were forcing the universal register to only be in one mode. And yeah, so we're going to go ahead and demonstrate the calculation we were asked. And it's going to be this number plus this number, and this is going to be the output. So let's go ahead and clear this. This is going to be decimal 9 and 13, and this is going to equal 20. So we're going to go ahead and load this. The thing with this is we're entering everything in serially and shifting left. So we are going to be entering everything in backward. So I have 1, 0, 0, 1. Okay, so we have this first one. This is going to be universal register B, and this is going to be our A. Right now we have these 4, and as I enter the next 4 bits, these are going to go in through our adder, and it's going to fill these 4 bits for universal register A. And then in the next 4 clock pulses, our Q3s are going to be added together, and it's going to be serially added into our register A while we are performing these calculations. So in 4 clock pulses, these bits will represent our sum. Where was I? Okay, so we're gonna now enter in our second number backwards. So it's gonna be 1, 1, 0, 1. So here we have 1, 1, 0, 1. And here we have our 3 or our 2 numbers we're about to add right here. And it's going to be least significant, most, least significant, most for these inputs. And so now after 4 clock pulses, these numbers will be reading our new output. So we can go ahead, does not matter these numbers because we're just performing our calculation. So we have 1, 2, 3, 4 clock pulses. And the way we're reading this is going to be our most significant bit because this is our carry out. So we have 1, and then we go up here, it's going to be our second bit, 0, 1, 0, 0, which is binary for decimal 20, which is our correct answer. Now, kind of diving more into this sequential circuit is we know that the universal register can have 4 different modes. We know that one of those modes is shift left. Shift left is going to be decimal for 2, binary for 1, 0. So S1 is always going to be 1, S0 is always going to be 0. So that's why it's connected to power, this is connected to ground. Same with this. So we're only ever going to shift left. It's of course connected to the same clock, and to enter in numbers, we are entering them in serially left. Okay, moving on in this little explanation. These 2 bits are the only ones being added, and because we are shifting everything left, each digit will be added. And then our sum gets routed back in just to universal register A, and that's why we read our output from universal register A. And then I showed the universal register in the last demo, but here it is. And then we can go ahead and also look at the full adder. And we went over this in previous lessons, but this is it. And yeah, let me just check this checklist. Oh, okay. Discuss the advantages and drawbacks of a serial adder sequential circuit compared to a parallel adder combinational circuit. So we can start with the serial adder sequential circuit. And this is going to be this. This is what we just did. We can see that there's going to be fewer components. And because we are only ever adding 2 digits, right here, our A and our B, it's going to require less power, and there's going to be less room for error. Drawbacks are that we are only ever adding these 2 bits, so it's going to be slow, and it needs to be connected to a clock. Whereas a parallel adder combinational circuit will be faster because it will add every single bit at the same exact time. It does not require a clock. That's what a combinational circuit just does it. It's just a calculation, it just does it. There's no memory, there's nothing, it just does the calculation asked or programmed to do. So because of that, it's going to have a simpler design, and there's not ever going to be a timing complications, which do come with any sequential circuit that requires a clock, or any sequential circuit. So drawbacks to a combinational circuit is that there's going to be more components. So for, say there's like 36 bits, you're going to need way more than just one full adder. And because they are adding, a combinational circuit adds all the bits at the same time simultaneously, it's going to require way more power, whereas this just needs one calculation powered. And then lastly, it's not synchronized. So say for a video game and whatnot, it needs a calculation done in order to perform the next task. It's going to be buffering for a while, or it's just not going to compile, and it's not going to end up doing what it's supposed to do because it's waiting on a calculation from a combinational circuit that's not hooked up to a clock. And I think that's it.